4 different scenarios will be analyzed in which the gap left by the depletion of conventional fossil fuels will be met by the following alternatives. Nuclear, assuming that no shortages of fuel may unfold, or that new technologies like breeder reactors or accelerator-driven systems are timely developed. Unconventional coal, assuming the development of technologies needed to access deeper seams, offshore or other constrained resources. Wind energy, both on its onshore and offshore forms. And finally solar energy. The following curves will show the number of new plants or equipments needed each year to fill the gap left by the fossil fuels. In this first scenario, it is shown how each of these energy sources can tackle the gap on its own. In this case, new equipments have to start being deployed in 2018, rising fast to a peak before 2040, and then slowly easing down. At peak, more than 2,500 TWh must be added from new infrastructure. By the end of the century, this sums up to 140,000 TWh generated per year. As a benchmark, this equates to more than 90 new nuclear power plants being built at peak, and more than 5,500 operating by century's end. The numbers for the other alternative sources in this scenario can be seen in the following table. The second scenario considers the case where 3 of these alternative energy sources are used simultaneously to fill the gap. This results in the previous numbers being divided by 3, with the following curves assuming that 2 other alternative energy sources are being stepped up simultaneously. In the case of nuclear, peak is now at 30 new nuclear power plants per year, reaching more than 1,800 operating by the end of the century. For the other alternatives, the numbers are the following. For the following scenarios, a worldwide improvement in energy efficiency used is factored in. This chart shows the relation between fossil fuel use and GDP per capita in several countries, both developed and developing nations, and excluding the Middle East oil producers. Knowing that the world average GDP per capita is $10,000 per year, it becomes apparent that current wealth standards should be sustained with just 5 barrels of oil equivalent per capita per year. Reflecting this relation, a model was thus developed in which annual energy use per capita slowly declines throughout the 21st century to 5 barrels of oil equivalent. In light of this model, the previous scenarios are revisited. The build-up curves are markedly different, showing 2 distinct phases of growth. At first, the alternative energy sources must grow rapidly to fill the gap, but as the efficiency wedge factors in, the build-up almost stalls by mid-century. Then, as the conventional fossil fuels reach their final days, the build-up has to slowly increase again. Again, a scenario where a single alternative is used. Infrastructure build-up now peaks just under 1,500 TWh added every year, summing 60,000 TWh of energy generated per year by 2100. These numbers equate to 55 new nuclear power plants per year at peak, and a total of 2,200 operating by the end of the century. This scenario for the remaining alternatives is the following. The last scenario looks into the case of 3 alternatives simultaneously tackling the gap, with the efficiency wedge helping along. Using nuclear once more as a benchmark, the build-up peaks at 19 new nuclear power plants per year, with the number of plants operating by 2100 down to 740. This scenario looks like this for the other alternative. And so ends this lookout at the road to the Olduvai Gorge. Conventional fossil fuels are set to peak in a decade, opening a considerable gap from today's energy use. Based on these finite resources, energy per capita is indeed headed to a cliff, likely leading to the Olduvai Gorge. But paths away from this end exist, even if apparently difficult to follow. A combination of different alternative energy sources, together with a serious engagement to energy efficiency, can extend the current standards of living towards the end of the century. The next 2 to 3 decades are crucial, where the fastest build-up of alternative infrastructure is needed. But the numbers contemplated here are not unsurmountable, and should be tackled with the right commitment and timely action. To all the humans facing the road to the Olduvai Gorge, good luck!